All right, today we're tackling a true giant in the Java world, the Spring Framework. If you've ever worked on a big Java project, you've probably bumped into it. But what is it really? Where did it come from? And why is it still so important after all these years? Let's get into it. So, to really get this, we've got to start with a big question. What was the one problem out there in enterprise software that was so huge, so massive, that it basically forced a complete rethink of how people built things with Java? The answer to that, well, that's the whole reason Spring even exists. And this right here, this is the whole idea in a nutshell. Think of it like building a house. You need pipes, you need wires, you need a foundation. That's the plumbing. Spring's goal was to handle all that complex, messy, behind-the-scenes stuff so that developers could stop being plumbers and start being architects, focusing on what the application actually needs to do. To really appreciate this, you have to rewind to the early 2000s. Back then, the standard way to build big Java apps was a technology called Enterprise Java Beans, or EJB. And look, it was powerful, for sure. But man, it was also a beast to work with. Super rigid, incredibly complex. You spent so much time writing boilerplate code and wrestling with configuration that your actual progress just crawled to a halt. So, all that frustration and complexity led to a truly revolutionary idea. And this idea is the absolute heart and soul of this Spring framework. It's a principle called inversion of control. So, what on earth is inversion of control, or IOC? Well, think about it like this. Normally, your code is the boss. It decides when to create an object, when to connect it to another object, when to get rid of it. Your code is making all the calls. IOC completely flips out on its head. You just tell the framework, hey, I'm going to need these pieces, and the framework takes over. It becomes the boss. It builds your components, manages them, and wires them together for you. The control is inverted. It goes from your code to the framework. And this chart, it really breaks it down. On the left, that's the old way. Your code is doing all the heavy lifting, creating its own objects, hunting down what it needs. This leads to code that's all tangled together. We call it tightly coupled. It's brittle and a nightmare to test. But on the right, with Spring, you just declare what you need. The framework's IOC container handles the rest. And the result? Your components are loosely coupled. They're independent, modular, and way, way easier to maintain and test. It's a total game changer. So how does Spring actually pull this off? It uses a technique called dependency injection, and it really just boils down to these 3 steps. First, you define your components, which in the Spring world are called beans. Step 2, you declare the dependencies. You say, okay, this payment service component needs a transaction manager component to do its job. And then step 3, you do nothing. You just let the Spring container work its magic, connecting or wiring everything together for you when the application starts. But hold on, because Spring isn't just this one-trick pony with inversion of control. Over the last 2 decades, it's grown into this massive ecosystem. It's less of a single tool and more like a fully stocked toolbox for building pretty much anything you can dream up in Java. At the very center of it all, you've got that core container doing the IOC magic we've been talking about. But built on top of that, you've got all these other modules. You need to build a website? There's a web module for that. Need to talk to a database? There's a data access module. Need to secure your app? Yep, there's a security module. It's the whole shebang. Let's just highlight a few of the heavy hitters here. Spring MVC is the absolute standard for building web apps and APIs in Java. Spring Data is amazing. It makes connecting to databases, whether they're old-school relational ones or modern NoSQL ones, almost trivial. Spring Security is the gold standard for authentication and authorization. I mean, it is the way you lock down your Java apps. And then you've got something cool like Spring AOP, which lets you handle things like logging or performance monitoring across your entire application without cluttering up your main code. Okay, so if you've heard of Spring in the last, say, 5 or 10 years, you've almost definitely heard of Spring Boot. See, while the original Spring framework was a massive improvement, you still had to do a fair bit of manual configuration to get it all working. Spring Boot came along to fix that final piece of the puzzle. I absolutely love this analogy. Let's go back to the house. If the original Spring framework gave you all the best pipes and fittings to do your plumbing, Spring Boot came along, paved a road to the house, put up the street signs, and gave you a key to the front door. It just gets you set up and ready to go with smart defaults, so you can start building immediately. And this is really the key difference. The Spring framework is all about power and flexibility. You can tweak anything. Spring Boot, on the other hand, is opinionated. It makes smart, sensible choices for you right out of the box. This is a principle called convention over configuration. So instead of you having to pick and set up a web server, Boot just includes one for you. Instead of you having to hunt down 20 different libraries, you just say, I need the web starter, and Boot pulls in everything you need automatically. What this all means is that Spring Boot lets you create apps that just run. Those starter packages simplify your whole setup. It automatically configures itself based on what it sees in your project. And best of all, there's no more wrestling with big, complicated XML files. It is laser-focused on one thing, getting you from an idea to a running, production-ready application as fast as humanly possible. So that brings us to the big question, right? In the tech world, things come and go so fast. Why is Spring, after 2 decades, not just hanging on, but actually more popular than ever? The answer is simple. It never, ever stopped evolving. Just look at this timeline. Spring has constantly adapted. It embraced modern Java 8 features back in 2013. In 2017, it introduced a completely new reactive programming model to power modern microservices. And just recently, it moved its entire baseline up to Java 17 to make sure it's always using the latest and greatest features of the language. It doesn't get stuck in the past. And that's really the story of Spring. It's a story of constant adaptation. The framework that started out as a way to escape complex XML files is now the absolute bedrock for building cutting-edge, cloud-native microservices. It has always evolved with the industry, anticipating what developers would need next. And that kind of leaves us with one last thought to chew on. We started this whole conversation by talking about managing complexity. Well, think about the world today. Cloud computing, microservices, distributed systems. Our applications are arguably more complex than they have ever been. So it begs the question, right? Is a framework that takes care of all that complicated plumbing not just still relevant, but maybe more essential now than ever before?